Okay, I'm just having a cup of tea. Right, hello everyone. I've put together a short video to explain the way in which I've chosen to wire my yacht out. I think you may agree that it is a versatile system, providing several advantages over a single 12-volt installation. One clear advantage is being of redundancy. Okay, I decided not to go down the lithium-ion battery route. Not because of the cost, but because I wanted to avoid the complications of needing the BMS monitoring and the risk of fire on board. I wanted something that was very robust. So I've chosen these Lock AGM with lead carbon technology. Now we've got 4 of these things on board. Now I've listed them as batteries. Battery A, Battery B, Battery C, Battery D. Battery A, Battery B are effectively in parallel to give us the 12-volt system. And Battery C and Battery D are in fact in series to give us a 24-volt system. Yeah, so I wanted something rugged, and I wanted to keep it simple. I know you may not think this is simple, but it's as simple as I could make it. Anyway, as the batteries are not actually designed for starting, I always run them in parallel. That's the engine batteries. These are the two 12-volt batteries I'm talking about here. This then, it shares the current when you start the engine. If you've got that selected to parallel, when you start the engine, it draws hopefully equal amounts of current out of each battery, because they're not primarily starter batteries. Although it would start the engine fine on one battery, but so as not to strain them. Yeah, and in fact, this keeps them connected as parallel. I'm trying to read off of what I've written here, actually. Yeah. It then always keeps the charge between the two in balance. That's what I've said. Okay, so the system. That is part of the system, the 12-volt and the 24-volt system. Charging. Okay, well, when you're in the marina, we've got a plug-in main socket here to plug in the marina main supply. There's a changeover main switch here, which means that if I'm at sea, I can select the output of a 3 kilowatt mains inverter. That goes into a consumer unit, which gives us there's a 16 amp MCB and a 6 amp MCB. 6 amp MCB basically runs the little 500 watt element in my calorifier hot water tank. It also runs the 12-volt battery power supply, and also comes down here and provides mains voltage to run the 24-volt charger to charge up the 12-volt system. Yeah, so that's that. The 16 amp output feeds all these 13 amp sockets. So I've got several around the boat, one in the rear cabin and 3 or 4 around the rest of the boat, one in the double cabin at the front, one in the saloon, and one on the navigation desk, double socket, and a single socket to run the kettle in the galley. Okay, and that also feeds, I might add, I should have drawn on there, that feeds the oven. So looking at to give you some idea of the practical aspects of these block diagrams that I've written here, I'll go through a couple of things. Right there, those are the batteries that are in the front, under the bunks in the front cabin. That's one of the 2 batteries that are in series to provide 24 volt. There is the consumer unit with an RCD 16 amp and a 6 amp breaker. There is the changeover switch to change between marina, that's in marina mains position, or 0 is off. Position 2 is the 3 kilowatt mains inverter. This is something slightly on a side that runs the bilge pump. It's when the that's in the auto position, and that's just an on-off switch. This is the immersion heater for the 500 watt element in the hot water tank. That's off at the moment on here. And then we've got this is the small switch that changes over. I'll show you that later. Come back to that. Okay, there's the 24 volt. It's a Noco Genius G15000 model. That can run at, that can charge 12 volt or 24 volt. It's running in 24 volt mode at the moment, and that will provide up to 12 amps to charge the front batteries up. This is the small mains inverter, 600 watt mains inverter that runs this. I'll come back to that as well. There's my electric convection oven, which is also a microwave with a non-rotatable table, so it's brilliant, absolutely brilliant. That's the 3 kilowatt mains inverter, slightly out of focus, but you can see that it's a full sine wave 3 kilowatt mains inverter. That is the 12 volt charging system. Note the solar panel regulator here and the selector box, which allows any combination of solar or battery charger to charge the 2 12 volt batteries. This is actually prior to me installing the new lock batteries, so these are the old batteries in there, but the new lock batteries are actually exactly the same size as this one here. Yeah. Now there's the new one of the new batteries. Notice that it's got a rating of 118 ampere hours with a 20-hour discharge. Okay. What else we got? Ah, that's the Noco Genius. That's a different model actually. That's the more expensive one. That'll provide 26 amps at 12 volt, or 12 volt, half that current, 13 amps at 24 volt. Now that's the type of changeover switch I've got on the 12 volt battery system. So it's battery 1, both batteries connected in parallel, battery 2 and off. Okay, I'll come back. There we are. So yeah, there's the output of that rotary switch. Now that will feed, that goes obviously to the alternator on the engine as well. That's a sort of like a common connection there. But that, and this is fused. I've left the fuses off, but there's a 30 amp fuse feeding this. Yeah, 30 amp fuse feeding that. I can go through the fuses later, and there'll be, I think, a 20 amp fuse feeding this little 600 watt mains inverter. So when we're running under engine and the alternator's pumping out plenty of juice, we can run this little inverter, which then can run this Noco Genius battery charger to charge the 24 volt system up. Okay, note that off this 24 volt system, you can run, I've got a 24 volt DC bilge pump, which is quite a heavy duty thing, so it draws half the current than the equivalent 12 volt one. I'm also going to fit a 24 volt anchor windlass. Again, draws half the current of a 12 volt one. Note here, I've got a 24 volt to 13.8 volt DC to DC converter, which I use to run the onboard computer. I run one of those little bricks box computers, runs Windows 10, and that's ideal because it gives me a backup supply other than the 12 volt system. Okay, so on the 12 volt system we've got a 100 watt solar panel that's up on the monkey frame at the back. That goes into this little solar regulator, which then goes into this charge selection box. I'll go to that now, just again there. So you can see you can charge you can select either battery. You could have this battery A running off the 12 volt charger and battery B running off the solar regulator, or vice versa, or both, or either. So that's wonderful, it works really well. Yeah, I think we've covered a lot of this now. Now there's the scenario, the thing that makes this redundant and gives you a lot of backup is that if my 12 volt system did go down, I can actually charge them back up from the 24 volt system. Now this can be done by, if you note, the 3 kilowatt mains inverter runs off 24 volts. So we can fire up the 3 kilowatt mains inverter and then run the 12 volt battery charger to charge up the 12 volt system. Now you may think that that's not very efficient, but these mains inverters, they're actually 90% efficient. So you're losing 10% in there, and these are 90% efficient, so you're losing 10% in there. So okay, let's say we're losing 20%. That's no great shakes, because it's better to do that and actually have this backup 24 volt supply. And if push come to shove, you can actually charge the 24 volt system up from the 12 volt by selecting this switch to run the 600 watt inverter, which will run this to run these. So 12 volts in there, through there, back to these batteries. So yeah, I'm pretty pleased with it. Let me know any ideas or comments that you've got. I'm going to probably do another video just to break down the actual currents and power requirements that the boat has. But I just thought I'd run through this as an overall system, see what your ideas are.